Welcome to the lesson on the Internet of Things. Upon completion of this lesson, learners will be able to define the Internet of Things, abbreviated as IoT, and its key components within manufacturing environments. They will be able to describe the IoT workflow and explain the interconnections between different IoT layers in manufacturing processes. Learners will also be able to analyze the application of IoT in electric vehicle battery manufacturing. The Internet of Things represents a system where physical objects incorporate sensors, software, and network connectivity to facilitate data collection and exchange between devices. This technological infrastructure enables devices to communicate and share information, forming connected systems that can operate together. The integration of these components allows objects to monitor their environment, process information, and interact with other connected devices within the network. This technology enables practical applications in daily life, such as a smart thermostat that learns household temperature preferences and adjusts automatically, while sending usage data to the homeowner's mobile device for monitoring and control. The key components of IoT consist of sensors and actuators that collect data and perform physical actions, network connectivity that enables communication between devices, data processing units that analyze and interpret information, and cloud infrastructure that stores and manages data while providing scalable computing resources. Let us now discuss how IoT works. The system operates through a systematic workflow consisting of four main layers. It begins at the physical layer, where devices and sensors collect real-world data, followed by the network layer, which handles data transmission through various communication protocols. The processing layer then analyzes and processes the collected data. The application layer presents insights and enables control through user interfaces. We will discuss these layers in detail in the following slides. First, let us take a look at the physical layer. This is where data collection begins in an IoT system. IoT devices and sensors collect real-world data such as temperature, pressure, and motion measurements. Edge devices then aggregate data from multiple sensors and perform initial processing before transmission to the next layer. Edge devices are computing devices that operate at the edge of a network, physically close to where data is being generated. They are positioned close to IoT sensors and data collection points, rather than in centralized data centers. The next layer is the network layer. This layer handles data transmission through various communication protocols. Gateways act as intermediaries between devices and the Internet, managing the flow of information. This layer supports multiple connectivity options, including Wi-Fi, cellular, and Bluetooth, to ensure reliable data transfer. In the processing layer, cloud platforms receive and store the raw data collected from devices. Data analytics tools then process this information to extract meaningful patterns. Artificial intelligence and machine learning algorithms analyze the processed data to generate insights and identify trends that can be used for decision-making. Finally, in the application layer, processed data is presented through user interfaces such as apps and dashboards, allowing users to monitor and control devices remotely. This layer completes the IoT workflow through a feedback loop that returns commands to devices, enabling interactive control and automation. Here's an example where IoT is implemented for EV battery manufacturing, grouped into the four layers as discussed earlier. The physical layer comprises various sensors strategically placed throughout the cleanroom environment. These include temperature monitoring sensors, maintaining precise conditions, humidity monitoring sensors, and particle monitoring sensors that track air quality at the microscopic level. The network layer serves as the communication backbone, utilizing a hybrid approach of Ethernet, Wi-Fi, Bluetooth, and 5G wireless networks depending on the availability. This multi-protocol network ensures real-time data transmission from the sensors to the processing systems, with built-in redundancy to prevent data loss or system downtime. In the processing layer, edge computing and gateway processing units handle the immediate analysis of sensor data. Edge computing devices perform real-time processing of environmental parameters, while gateway processing manages data aggregation and protocol conversions. This layer acts as the bridge between raw sensor data and actionable information. Finally, the application layer represents the intelligence of the system, where monitoring and control functions are executed. Real-time dashboards display current conditions, while advanced analytics track data trends. This layer also enables predictive maintenance scheduling and energy optimization through sophisticated algorithms. For instance, if temperature trends indicate potential heating or cooling system issues, the predictive maintenance system can schedule interventions before problems affect production. This integrated IoT approach ensures consistent battery quality by maintaining precise environmental conditions, reducing defects through early detection, and optimizing energy consumption in the manufacturing process. The system's ability to collect, process, and act on real-time data has become crucial for maintaining the high standards required in EV battery production. In summary, IoT connects devices, networks, and systems to enable real-time data flow for better manufacturing decisions. The four-layer IoT architecture, which includes physical, network, processing, and application, creates a framework for smart manufacturing implementation. In EV battery production, IoT ensures quality through precise environmental monitoring and control. Finally, real-time analysis and predictive maintenance optimize production efficiency and reduce costs. This integrated approach demonstrates how IoT transforms traditional manufacturing into data-driven intelligent operations. Thank you.